Hello there, and welcome. Tonight, we're going to drift into the ever-changing world of weather. The endless dance of sky and storm, but surrounds us every single day. The sky above our heads may seem simple, but it is full of chaos and wonder. It is a living ocean of air, rippling with winds, painted with clouds, and stirred by invisible rivers of heat. In this fragile system, sunlight scatters into colors, lightning splits the sky with fire, and storms are born that can cross entire oceans. Weather is not only the mood of the planet, it is its breath, its heartbeat, its song. If you enjoy these gentle science journeys, I invite you to like and subscribe, or share one of your favorite facts in the comments below. It helps others find their way here too, one sleepy soul at a time. But for now, there's nothing you need to do but rest. Settle in, breathe deeply, and allow your mind to wander into the fascinating world of weather. Let's begin. A single storm cloud can weigh more than 1,000,000 elephants. When you look up at a drifting cloud, it seems soft and weightless, almost like cotton pulled across the sky. But the truth is astonishing. A typical cumulus cloud, the kind that floats on a summer afternoon, can hold hundreds of thousands of tons of water. All those droplets, too small to see individually, add up to an unimaginable mass, heavier than 1,000,000 elephants standing side by side. And yet, the cloud floats, suspended because the water is spread out into countless microscopic drops, each carried upward by rising warm air. The sight of something so immense, so heavy, yet appearing delicate and ethereal, is one of the great paradoxes of weather. The next time you tilt your head to watch a cloud drift lazily above you, remember that it carries the weight of entire lakes in its gentle embrace. Lightning is hotter than the surface of the sun. In the blink of an eye, a jagged bolt of lightning splits the sky. It looks like pure white fire, but its true temperature is even more startling. A lightning strike can reach over 30,000 degrees Celsius, making it several times hotter than the surface of the sun. The energy involved is staggering, powerful enough to superheat the air around it, turning it into plasma and igniting the sky with blinding brilliance. That sudden expansion of air is what we hear as thunder rolling across the landscape. Each flash of lightning is like nature's own laboratory experiment, compressing unimaginable heat and energy into a fraction of a second. Some bulbs travel miles, connecting sky and ground in a shimmering chain. For all its violence, lightning is also life-giving. It helps fix nitrogen into the soil, feeding the very plants that sustain us. The sound of thunder is air exploding from sudden heat. Thunder rolls low and deep across the sky, sometimes like distant drums, sometimes sharp and startling. What we are really hearing is the voice of lightning. When lightning flashes, it heats the air so quickly and so intensely that the molecules cannot keep up. They expand in a violent rush, creating a shockwave that races outward faster than the speed of sound. That shockwave is thunder. Depending on your distance, the sound may crack, rumble, or echo between hills and buildings. Because light travels much faster than sound, we see the flash long before the noise reaches us, which is why counting seconds between lightning and thunder can reveal how far away the storm is. In this way, thunder is both a warning and a wonder, a reminder of the immense forces at play above us, wrapped in the rolling rhythm of the storm. Raindrops are not teardrop-shaped at all. Children's drawings often show raindrops falling like perfect teardrops, pointed at the top and rounded at the bottom. But in reality, raindrops are nothing like that. The smallest drops are almost perfectly spherical, held together by surface tension. As they grow larger, air resistance flattens their bottoms, giving them a shape more like a hamburger bun than a teardrop. If they grow too big, they can no longer hold together and break apart into smaller droplets. This subtle detail makes rain even more beautiful when you imagine each drop tumbling from the sky in its own perfect form. The illusion of teardrops comes from how falling water looks on windows or cheeks, stretched by gravity as it slides downward. But the raindrops drifting down onto fields, roofs, and rivers carry their own hidden geometry, tiny, rounded jewels, not the sharp shapes we imagine. The smell of rain comes from ancient oils and cosmic particles. There is a word for the earthy, comforting fragrance that rises after a rainstorm: petrichor. This scent is created by a blend of remarkable ingredients. Tiny plants release oils into dry soil during long stretches without rain. When raindrops strike the ground, they break bubbles in the soil that carry these oils into the air. At the same time, another compound called geosmin, produced by soil-dwelling microbes, fills the air with its rich, earthy perfume. And during storms, lightning can split molecules of oxygen and nitrogen, creating ozone, which adds a sharp, fresh note to the mix. The result is the unmistakable smell of rain, a scent tied to ancient soils, living microbes, and even the chemistry of the sky itself. When you inhale that fragrance, you're breathing in a story as old as Earth and as wide as the atmosphere. Snowflakes can fall at vastly different speeds. We picture snow drifting silently, each flake twirling in slow motion. And while some snowflakes really do float gently, others fall surprisingly fast. The speed depends on their size and structure. Small, delicate crystals may descend at just a tiny fraction of a meter per second, hovering in the air as though reluctant to land. Larger flakes, made of many crystals stuck together, can tumble down at speeds closer to a few meters per second. Wind currents complicate things further, tossing flakes sideways, upward, and in spirals. In some cases, flakes are carried for miles before they finally reach the ground. So when you see snow falling, you are watching a ballet choreographed by air resistance, gravity, and the hidden architecture of ice. Every descent is unique, a quiet journey through the atmosphere before settling into the white hush of winter. Some snowflakes are wider than a coin. Most snowflakes are small, delicate crystals no bigger than a fingernail. But under the right conditions, they can grow to extraordinary sizes. Moist air, gentle winds, and just the right temperature can allow flakes to stick together, forming clusters wider than a coin, or even as large as a dinner plate. The biggest snowflakes on record were reported in Montana in the late 1800s, said to be more than 15 inches across. Imagine such immense flakes tumbling slowly from the sky, like icy feathers drifting down. While most of us will only ever see flakes the size of coins or smaller, knowing that the sky can produce such giants adds a touch of magic to winter storms. Each flake, no matter how large or small, carries within it the complex geometry of ice crystals, grown in silence high above the earth. Blizzards can make it impossible to see your own hand. blizzard is not just a heavy snowfall, it is a storm where wind and snow combine into a blinding wall. In the midst of one, visibility can drop to just a few feet. Travelers caught in such conditions sometimes describe being unable to see their own hands held out in front of them. The snow is whipped into the air by powerful gusts, creating a swirling whiteout where all sense of direction vanishes. Temperatures plummet, and wind chills can freeze exposed skin in minutes. To those living on open plains or high mountains, blizzards are among the most dangerous weather events, capable of disorienting even experienced explorers. And yet, within the storm's ferocity, there is also a strange beauty. The transformation of the world into a blank canvas of white, where silence and chaos exist at the same time. Hailstones can grow in perfect layers, like onions. When the thunderstorm's updraft is strong enough, raindrops are carried high into the colder layers of the cloud, where they freeze into tiny pellets of ice. These pellets may then fall back down, gather more water, and be lifted again, freezing layer upon layer in the process. By the time they finally fall to Earth, hailstones may carry dozens of concentric rings, like the growth rings of a tree or the layers of an onion. Sliced open, they reveal their hidden history, each layer a record of a journey through the storm. Small hailstones may be harmless, but larger ones can shatter windows, flatten crops, and dent cars. The largest can weigh more than a pound. Even so, they are natural sculptures carved by the turbulent breath of clouds, carrying the memory of the storm in their icy design. The largest hail ever recorded was bigger than a volleyball. In July 2010, in the small town of Vivian, South Dakota, an astonishing piece of hail fell from the sky. It was nearly the size of a volleyball, 8 inches across and weighing almost 2 pounds. Imagine such a sphere of ice hurtling toward the ground at high speed. Fortunately, it landed in a field rather than striking a home or person, but it remains the largest hailstone ever measured in the United States. Around the world, storms have produced other enormous hailstones, each formed by powerful updrafts that carried them up and down inside storm clouds, layering ice upon ice. Most hailstones are no larger than peas, but records like Vivian's remind us of nature's extremes. The sky, under rare conditions, can produce ice missiles of terrifying size, forged by turbulence and then hurled back down to Earth. Tornado winds can fling straw through solid wood. Tornadoes are among nature's most astonishing forces, twisting across the land with winds so strong they can turn the ordinary into the unthinkable. One of the strangest pieces of tornado lore is also true. Lightweight straw in the grip of a tornado can be driven straight through solid wood. The winds accelerate debris to such extraordinary speeds that even the gentlest objects become piercing projectiles. Pieces of straw have been found embedded in fence posts, utility poles, and even the walls of houses after a storm. It's a reminder of just how violent the air can become when it spins into a vortex. The tornado doesn't need heavy weapons. It can turn grass into arrows. To stand in the path of such a storm would be to face a force that bends the rules of everyday reality, where fragile things become instruments of destruction. The fastest tornado winds rival the speed of a jet plane. When we think of powerful winds, we may picture hurricanes or powerful storms at sea. But tornadoes leave even those in the dust. The most intense tornadoes, called EF5s on the enhanced Fujita scale, have winds measured at more than 300 miles per hour, comparable to the cruising speed of a passenger jet. In such winds, cars can be tossed into the air like toys. Steel beams can be bent or twisted, and entire buildings can vanish from their foundations. Storm chasers who have survived close encounters describe the roar of these winds as sounding like a freight train bearing down, unstoppable and immense. Thankfully, tornadoes of such intensity are rare, but knowing they exist is enough to inspire awe. They are the planet's most concentrated bursts of atmospheric fury, a reminder that the air around us can sometimes move with unimaginable speed. Hurricanes release more energy than every power plant on Earth combined. A hurricane is a storm on a scale that almost defies comprehension. Spanning hundreds of miles, fueled by warm ocean waters, it gathers moisture and heat, building into a vast spinning engine. The energy released in a single day by a mature hurricane is greater than the energy used by all of humanity's power plants combined. Imagine every coal plant, every nuclear reactor, every wind turbine and solar panel feeding electricity into one grid, and still falling short of the output of a single storm. Most of this energy is released as heat, carried away by the condensation of billions of raindrops, while the rest is unleashed as fierce winds and pounding waves. To stand near a hurricane's edge is to feel just the faintest brush of its power, while satellites from space can only capture its swirling immensity. It is Earth's most spectacular weather machine. The calmest part of a hurricane is at its violent center. Step into the eye of a hurricane, and you will find something almost unbelievable. After hours of howling winds and torrential rain, a sudden silence falls. The air clears, the clouds part, and sometimes the sun even shines. This is the eye, a circular region at the heart of the storm, often 20 to 40 miles wide. Here the winds calm and the sea surface steadies. But it is not a place of safety. Surrounding the eye is the eye wall, a towering ring of thunderstorms where the storm's winds reach their absolute peak. The eye is like the still heart of a spinning wheel, calm only because the chaos rages so fiercely around it. For those who have experienced it, the eye is eerie, peaceful, beautiful, and filled with dread, because they know that after a brief pause, the storm will return with full force. Monsoons can transform entire landscapes in a single season. In many parts of the world, life is tied to the rhythm of the monsoon. These are seasonal winds that shift direction, bringing with them immense rains. For months, parched lands may lie dry and cracked, waiting for relief. Then, almost overnight, the skies open. Rivers swell, fields flood, and forests come alive with green. The monsoon rains are both life-giving and destructive. They water crops that feed hundreds of millions, but they can also unleash floods and landslides that reshape the land. In India, Southeast Asia, and parts of Africa, whole cultures and histories have grown in harmony with the cycle of the monsoon. Farmers plant and harvest according to its timing festivals, celebrate its arrival. To witness a monsoon is to see whether on a continental scale, a turning of the atmosphere so vast it changes the face of nations. The Atacama Desert can go decades without a drop of rain. There are dry places, and then there is the Atacama. Stretching across northern Chile, it is considered the driest non-polar desert on Earth. Some weather stations in the Atacama have never recorded a single drop of rain, and parts of it may go decades without measurable precipitation. The soil is so barren that NASA has studied it as an analog for Mars. Yet even here, life finds a way. Certain plants draw water from fog drifting in from the coast, while microscopic organisms cling to existence deep in the ground. On rare occasions when rain does fall, the desert explodes into color. Wildflowers bloom across the sands in a spectacle called the Desierto Florido. To stand in the Atacama is to feel the silence of a place almost untouched by weather, where the sky is vast and every drop of water is a miracle. The wettest place on Earth is soaked by walls of rain. In northeastern India lies the village of Mausanram, often called the wettest inhabited place on Earth. Each year, monsoon winds from the Bay of Bengal funnel into the surrounding hills, forcing moist air upward. The result is astonishing. An average rainfall of nearly 12 meters per year. Imagine rain so heavy that rivers roar down streets, waterfalls surge from cliffs, and the sound of water is a constant companion. Roofs are built of sturdy materials to withstand the deluge, and villagers even weave living root bridges to cross the swollen streams. Life here is shaped entirely by rain. While most people measure precipitation in inches or centimeters, in Mausanram, it is measured in towering walls of water that return every year, without fail. It is a reminder that weather is not evenly spread. Some places drown in rain, while others thirst endlessly. The hottest temperature ever recorded could melt car tires. In July of 1913, in Death Valley, California, a furnace-like wind swept across the desert floor. The official temperature measured was 56.7 degrees Celsius, 134 degrees Fahrenheit, the hottest ever reliably recorded on Earth. At such heat, asphalt softens, metal sears to the touch, and car tires risk melting if driven too long. The body struggles to shed warmth, and even in the shade, survival becomes difficult without water. Death Valley earned its name from such extremes, where daytime heat rises off the rocks in shimmering waves. Though other places, like Kuwait or Iran, have come close, Death Valley still holds the crown. The fact that such temperatures exist on our own planet is a stark reminder of the atmosphere's power. The air above us is not just mild and gentle, it can become a blazing, deadly furnace. The coldest air on Earth can freeze metal in seconds. At the heart of Antarctica, on a high plateau far from the sea, lies a place where the air itself feels alien. Here in 1983 at Vostok Station, scientists recorded a temperature of -89.2 degrees Celsius, colder than dry ice, cold enough to make steel brittle and shatter glass. More recently, satellites have measured even lower readings in nearby hollows, approaching -98 degrees. In such conditions, breath freezes into crystals, machinery locks up, and exposed skin can freeze solid almost instantly. This is colder than the average surface of Mars. To live here requires extraordinary preparation, with heated shelters, insulated suits, and constant vigilance. Yet, even in this frozen heart of Earth, weather still moves, winds howl, snow drifts, and clouds pass slowly overhead. It is the ultimate frontier of cold, where Earth's atmosphere meets its most extreme silence. Heat waves kill more people than any other type of extreme weather. Storms and floods often make headlines, their power visible and dramatic. But the deadliest form of weather is far quieter, the heat wave. When air grows still and temperatures soar for days or weeks, the human body begins to struggle. Without relief, heat stress builds, straining hearts and dehydrating tissues. Cities suffer most, where asphalt and concrete absorb heat, creating islands of stifling air. Nights offer little respite as buildings release the warmth stored during the day. Around the world, heat waves have claimed tens of thousands of lives, often silently, affecting the elderly, the very young, and those without shelter. Unlike a storm, you may not see its violence, but it is there, in rising hospital admissions, in fields of withered crops, in overheated rivers where fish die by the thousands. Heat waves are weather's most insidious threat, creeping in quietly but with devastating power. Fog can be so thick you can't see your own feet. Fog is one of weather's quietest tricks, a cloud lowered to the ground, wrapping the world in pale silence. Usually, it makes the horizon vanish, blurring buildings and trees into ghostly shapes. But in rare cases, fog can become so dense that visibility shrinks to just a few feet, and people walking through it describe being unable to see their own feet clearly. In this kind of fog, sound behaves strangely too, muffled and close, as though the air itself is thick. Airplanes are grounded, ships slow to a crawl, and drivers are forced to inch forward in eerie caution. Despite its softness, fog can be one of the most dangerous weather events. And yet, to walk through it can feel otherworldly, like moving inside a dream where the edges of reality have dissolved, leaving only whiteness and the sound of your own breath. Dew can collect enough water to sustain life in deserts. In the dry silence of deserts, rain is often a rarity, but dew is a quiet savior. As the sun sets, the ground cools quickly, and if the air temperature dips below a certain point, moisture condenses onto rocks, leaves, and even the smallest grains of sand. Each morning, the desert wakes adorned with tiny beads of water. For plants and animals that have evolved to survive here, this dew can mean the difference between life and death. Beetles tilt their bodies to catch droplets that slide into their mouths. Certain plants channel dew down their stems toward thirsty roots. Even humans have learned to harvest it, using nets or surfaces designed to collect these shimmering jewels of water. Though each droplet is small, together they provide sustenance in places where rain may not fall for months. Dew is desert rain, delivered in whispers instead of storms. Frost crystals can grow into spiky forests of ice. On winter mornings, frost sometimes paints delicate patterns on windows, curling leaves, fern-like tendrils, shimmering lace. These are ice crystals, forming as water vapor freezes directly onto a cold surface. But in the right conditions, frost can grow into something much larger and stranger. On mountain peaks and polar plateaus, frost can form spiky forests of ice, known as hoarfrost. Here, the crystals stretch upward into jagged towers, sometimes inches long, catching the morning light like glass sculptures. Each spike grows as vapor condenses onto its surface, layer upon layer, until the whole landscape bristles with frozen blades. In the stillness of cold air, they remain fragile, crystalline, and sharp. Step too close, and they crumble at the touch. Yet, for as long as they last, they transform the ordinary world into something otherworldly, a forest of ice, born from nothing more than cold air and breath. Ice storms coat cities in a dangerous glassy shell. There is beauty in an ice storm, but it is the kind of beauty edged with danger. When rain falls through a layer of freezing air close to the ground, the drops turn to supercooled liquid, still liquid as they fall, but ready to freeze the instant they touch a surface. Roads glaze into sheets of invisible ice. Tree branches turn into crystal sculptures, and power lines sag under their sudden weight. At night, headlights catch the frozen world in shimmering reflections, every twig and blade of grass encased in glass. But beneath this brilliance lies danger. Roads become impassable, trees snap, and whole neighborhoods may lose power for days. To walk outside during an ice storm is to move through a fragile world of frozen jewels, where every surface is slick and treacherous. It is weather at its most deceptive, breathtaking, but perilous. Dust devils can rise taller than skyscrapers. On a hot, dry afternoon, the ground can heat unevenly, sending columns of warm air spiraling upward. Sometimes, this air begins to spin, forming a dust devil. Many are small, swirling just a few feet across, but some grow to astonishing heights, twisting towers of dust rising taller than skyscrapers. Unlike tornadoes, dust devils form under clear skies, dancing across deserts, fields, and even parking lots. Harmless ones flick leaves and sand, but the largest can topple fences, lift roofs, or hurl debris across the ground. Pilots have reported seeing massive dust devils from the air, towering over the land like temporary giants. They are brief, chaotic, and mesmerizing. Miniature whirlwinds that reveal how alive the atmosphere is, even on days that appear calm. To watch one is to see the invisible currents of heat and air made suddenly, dramatically visible. Waterspouts can spin across the ocean like watery tornadoes. Imagine standing on a shoreline and seeing a slender, twisting column rise from the sea, stretching up to the clouds above. This is a waterspout, a vortex of air and mist, shaped like a tornado but formed over water. Some are relatively weak, spinning harmlessly across bays or lakes before vanishing. Others are powerful enough to toss boats, snap masts, and whip waves into frenzy. Fishermen have long told stories of waterspouts looming like ghostly funnels on the horizon. From a distance, they can be strangely beautiful, spirals of silver mist gliding across the sea, lit by sunlight or lightning. But up close, they are forces of chaos, blending storm winds with ocean spray. Waterspouts are reminders that tornado-like fury is not confined to land. Even the calm, open sea can suddenly twist into a whirling tower of water reaching for the sky. Microbursts can slam planes out of the sky. Microbursts are among the most dangerous and least visible threats in weather. They occur when a thunderstorm suddenly dumps a mass of cool air, which plunges toward the ground and spreads outward at high speed. To those on the ground, a microburst may feel like a sudden, violent blast of wind, knocking down trees or flattening fields. But for airplanes, the danger is far greater. A plane flying into a microburst may suddenly lose lift, forced downward faster than the pilot can react. Several accidents in the past revealed their deadly potential, leading to new safety systems that detect them. Microbursts are short-lived, sometimes lasting only minutes, but their power is immense, with winds exceeding 100 miles per hour. Invisible until they strike, they show how storms can unleash fury not just in lightning and rain, but in sudden, catastrophic blasts of air. Supercell storms can grow larger than entire states. Most thunderstorms are small, localized events, lasting less than an hour. But supercells are different. They are massive, organized storms with rotating updrafts that can last for many hours. On satellite images, they can stretch across hundreds of miles, sometimes larger than entire US states. Within their towering clouds, which can rise more than 10 miles into the sky, whole weather systems come to life. Lightning flashing thousands of times per minute, hailstones forming layer upon layer, tornadoes spinning Jimmery into existence. Supercells are rare, but they are the engines of the most destructive weather on Earth. To watch one forming from a distance is to see the atmosphere flex its muscles, a dark, rolling wall of cloud, so vast it reshapes the horizon itself. They are storms that seem alive, breathing, rotating, and growing until the land beneath them feels small. Some thunderstorms can last for more than 12 hours. We often think of thunderstorms as fleeting, a quick burst of lightning, a downpour, and then clearing skies. But under the right conditions, thunderstorms can endure far longer. Systems called mesoscale convective complexes can persist for 12 hours or more, traveling across entire regions while maintaining their intensity. Within them, waves of storms rise and collapse in a self-sustaining cycle, feeding on warm, moist air and releasing torrents of rain. These long-lived thunderstorms can cause widespread flooding, lightning outbreaks, and powerful winds. From above, they appear as sprawling masses of cloud, glowing with flickering lightning like a living organism. For those beneath them, the storm becomes a companion through the night. Never-ending rumbles, repeated flashes, rain that seems endless. They remind us that weather is not always a brief event. Sometimes, the sky itself settles in for a long and restless stay. There is a storm in Venezuela that has produced lightning for centuries. Over the mouth of the Catatumbo River in Venezuela, a storm has been raging for centuries. Known as the Catatumbo lightning, it is a natural phenomenon where lightning storms occur almost nightly, sometimes for 10 hours at a time, for more than 200 nights each year. The unique geography of the region, warm winds from the Caribbean colliding with cold air from the Andes, creates a perfect recipe for constant storms. From miles away, the sky above Lake Maracaibo glows with flickering light, a silent fireworks display seen even by sailors far out at sea. For generations, people have called it the Lighthouse of Maracaibo, a beacon visible without end. Scientists are still studying why this location is so uniquely storm-prone. But one thing is certain: nowhere else on Earth does lightning pulse with such relentless, timeless rhythm. Weather balloons can rise higher than Mount Everest. Every day, hundreds of weather balloons are released around the world, carrying instruments called radiosondes into the sky. They look simple, just large balloons filled with helium or hydrogen. Yet they climb to extraordinary heights. Rising at about 1,000 feet per minute, they drift far above airplanes, far above clouds, into the stratosphere itself. By the time they burst, they may be over 20 miles high, soaring much higher than Mount Everest. At those altitudes, the air is so thin and cold that temperatures plunge to -90 degrees Celsius, and the horizon curves against the black of space. As they rise, these balloons measure temperature, pressure, humidity, and wind, sending back data that allows us to forecast the weather days ahead. Though unseen by most of us, they are explorers of the atmosphere, silent travelers that map the invisible ocean of air around our planet. Satellites can see hurricanes from space in real time, orbiting hundreds of miles above Earth. Weather satellites watch over us like silent guardians. When hurricanes form over the oceans, satellites capture their spiral arms stretching across hundreds of miles, their eyes open like immense pupils staring upward. From space, a hurricane is breathtakingly beautiful, a swirling geometry of clouds, endlessly rotating. But within those graceful patterns lies devastating power. Modern satellites can track these storms in real time, mapping rainfall, measuring wind speeds, and even peering inside with infrared sensors to watch the heat signatures of clouds. This constant vigilance saves lives, giving coastal cities precious hours or days to prepare. Before satellites, storms would strike with far less warning. But now we can watch them grow, travel, and eventually fade back into the sea. From the cold silence of orbit, satellites see Earth's most violent storms not as chaos, but as mesmerizing, living patterns. Doppler radar can track raindrops moving through the air. When a storm approaches, the familiar green and red patterns on weather maps are made possible by radar. But modern Doppler radar does far more than simply detect rain. By bouncing radio waves off raindrops and snowflakes, it can measure not only their location, but also their speed and direction. This allows meteorologists to see inside storms in astonishing detail, tracking rotation that might spawn tornadoes, or spotting bands of heavy rain that could lead to flooding. In effect, Doppler radar turns the invisible movements of the atmosphere into a visible map, a portrait of swirling chaos translated into color. Each pixel of red, green, or purple represents countless droplets tumbling through the sky. For those who know how to read it, Doppler images are like fingerprints of storms, revealing their hidden structure and letting us glimpse the choreography of weather as it unfolds above our heads. The northern lights are a form of space weather. High above the polar regions, shimmering curtains of green, purple, and red dance across the night sky. These are the northern lights, or aurora borealis, and though they look like earthly weather, their origin is cosmic. Streams of charged particles from the sun collide with Earth's magnetic field, funneled down toward the poles. When they strike atoms in the upper atmosphere, they excite them, causing them to glow. What we see as shifting ribbons of light is the atmosphere itself coming alive. This is not just weather of the Earth, but space weather. A reminder that our atmosphere is a shield against the sun's constant stream of energy. Watching the aurora is like witnessing Earth's magnetic heartbeat, a direct link between solar storms and the fragile veil of gases that protect our world. It is cosmic poetry, written in light across the sky. Solar storms can disrupt Earth's weather systems. When the sun erupts with a solar storm, clouds of plasma and magnetic energy stream across space at astonishing speeds. These storms can strike Earth in just a couple of days, rattling our magnetic field and sparking brilliant auroras. But they can also reach deeper, disrupting satellites, power grids, and even atmospheric circulation. Some scientists believe strong solar storms may temporarily influence weather on Earth by altering the way the atmosphere absorbs energy. These connections are subtle and not fully understood, but they remind us that Earth's weather is not sealed off from space. We live within the sun's extended reach, our atmosphere constantly stirred by its invisible hand. Even when skies are clear, solar storms can ripple through the fabric of our environment. In this sense, Earth's weather is never entirely its own. It is part of a larger conversation with the star that sustains us. Even jet contrails can change local cloud cover. Look up on a clear day, and you may see the long, thin trails left by airplanes crisscrossing the sky. These contrails, formed from exhaust mixing with cold, moist air, can linger and spread, merging into thin, cirrus clouds. Though they seem delicate, contrails can alter local weather by changing how sunlight and heat move through the atmosphere. In some regions, widespread air traffic has been shown to increase cloud cover noticeably, subtly warming nights and cooling days. After the September 11th attacks in 2001, when flights were temporarily grounded in the United States, scientists observed unusual swings in day and night temperatures, a hint of how much contrails normally influence the balance. It is a reminder that even small streaks of human activity can ripple outward into the great ocean of weather, painting the sky and shifting the planet's breath in ways we seldom notice. Flash floods can move boulders the size of cars. Water is usually gentle, carving valleys over centuries, wearing down mountains grain by grain. But in a flash flood, water shows its other face, sudden, furious, unstoppable. When torrential rain falls in a short time, rivers can swell in minutes, and dry gullies can become roaring torrents. These walls of water carry with them sand, branches, and even boulders weighing tons. Entire cars can be lifted and swept away. Streets turn into rivers, bridges crumble, and landscapes are rearranged overnight. Flash floods are especially dangerous because they arrive with little warning, often under skies that seem deceptively calm just upstream. For those caught in their path, the power of moving water is unforgettable. It is the voice of gravity, magnified by storm, reminding us that weather can turn the softest element, water, into one of Earth's most devastating forces. Some droughts have lasted for hundreds of years. When the rains fail, the world changes slowly but profoundly. Crops wither, rivers shrink, and soils crack. Most droughts last for months or years, but in the geological past, some have stretched for centuries. These megadroughts have left scars in tree rings, lake beds, and even the ruins of vanished civilizations. In North America, evidence shows that the western United States endured droughts lasting hundreds of years during the medieval period, far longer than anything seen today. Such droughts reshape entire regions, transforming forests into grasslands, grasslands into deserts. People are forced to migrate, abandon settlements, or adapt in extraordinary ways. Drought is a silent kind of weather. No storms, no thunder, no spectacle. Just an absence, stretching on and on, until landscapes and histories bend beneath it. In its quiet way, a drought can be every bit as powerful as a hurricane or a flood. El Niño can shift weather across the entire planet. Every few years, the Pacific Ocean warms in a phenomenon called El Niño, and when it does, the atmosphere responds. Winds shift, currents change, and weather patterns ripple outward across the globe. South America sees torrential rains, while parts of Asia endure drought. Hurricanes, monsoons, and even winter storms in North America can all be altered by the pulse of El Niño. What begins as a change in ocean temperature near the equator cascades into consequences felt thousands of miles away. It is one of the clearest demonstrations of how interconnected Earth's systems are. The ocean and the atmosphere moving in rhythm, touching weather on every continent. For farmers, fishermen, and scientists, El Niño is both a challenge and a mystery, a reminder that the heartbeat of the planet's climate is set not by one place alone, but by the vast ocean currents beneath the sky. La Niña brings the opposite effect in cooling winds. After El Niño often comes its opposite, La Niña. During these periods, the Pacific Ocean's surface cools, and the winds that sweep across it strengthen. The effects are just as global, but reversed. Drought may strike where rains once poured, hurricanes may form in new regions, and winters in some parts of the world grow harsher. La Niña is part of a natural cycle, a swinging pendulum of heat and cold in the equatorial Pacific that resonates through the whole atmosphere. Though invisible to the eye, these shifts are powerful enough to alter rainfall in Africa, typhoons in Asia, and storm tracks across North America. To think that the cooling of ocean waters in one part of the globe can steer weather thousands of miles away is to glimpse the planet's deep interconnectedness, an Earth whose weather is truly one great system. Ocean currents act like giant rivers of heat. Beneath the ocean's surface flow currents so vast and steady that they resemble hidden rivers. Unlike rivers of fresh water, these currents are driven by temperature, winds, and the rotation of the Earth. They transport enormous amounts of heat around the globe, redistributing the sun's energy and balancing the climate. Warm water from the equator drifts toward the poles, while colder water sinks and slides back toward the tropics. Without these invisible rivers, much of Earth would be uninhabitable, with sweltering equatorial zones and frozen mid-latitudes. Instead, currents act as Earth's hidden thermostat, moderating extremes. From space, the swirling gyres they form look like spirals of living art, vast enough to cover oceans. To stand on a shore and feel a warm current brushing past your feet is to touch the edge of a system that ties continents together, an endless flow linking all weather. The Gulf Stream helps keep Europe warm in winter. Europe lies far north, on the same latitude as Canada, yet winters there are much milder. The reason flows across the Atlantic Ocean, the Gulf Stream. This powerful current carries warm water from the Gulf of Mexico northeastward, releasing its heat into the air as it travels. By the time it reaches Europe, the air above it is warmer than it otherwise would be, softening the chill of winter. Without the Gulf Stream, much of northern Europe would face climates closer to Siberia's, with harsher winters and shorter growing seasons. Farmers, cities, and entire cultures are shaped by this steady river of warmth. Scientists continue to watch it closely because shifts in the Gulf Stream could have dramatic impacts worldwide. For now, though, it remains one of Earth's most important lifelines, a conveyor of heat, a hidden partner in the dance of weather and climate. The polar vortex can push Arctic cold into the south. Far above the North Pole swirls a mass of icy air known as the polar vortex. Normally, this frigid circulation is trapped high in the atmosphere, contained by strong winds. But sometimes it weakens and wobbles, spilling Arctic cold southward. When this happens, regions far from the poles, places like the American Midwest or Central Europe, suddenly find themselves in the grip of extreme cold, with temperatures plunging to dangerous levels. These outbreaks can freeze rivers, paralyze cities, and shatter records. The term polar vortex has become familiar in news headlines, but the phenomenon is not new. It is part of the natural rhythm of Earth's atmosphere, a reminder that the Arctic is not sealed away, but connected to us all. The next time icy air sweeps unexpectedly across your city, you may be feeling the edge of that vast spinning crown of cold. A volcanic eruption can change weather worldwide. When a volcano erupts with immense force, its effects can be felt far beyond the mountain itself. Explosive eruptions blast ash and gases high into the stratosphere, where winds spread them around the globe. Tiny particles of sulfur dioxide can linger for months or even years, reflecting sunlight and cooling the planet. The eruption of Mount Tambora in 1815 caused what became known as the Year Without a Summer, bringing frost and famine across the northern hemisphere. Crops failed, rivers froze in midsummer, and skies turned hazy with ash. More recently, the eruption of Mount Pinatubo in 1991 lowered global temperatures for several years. Volcanic eruptions are a stark reminder of how tightly linked Earth's systems are. A mountain's fury can alter the balance of sunlight and air worldwide. In weather, even the fire of the Earth itself has a voice, whispering through the clouds and storms. Forest fires can create their own lightning. When a forest burns with intense heat, flames can rise hundreds of feet into the air. The heat drives powerful updrafts, lifting ash and smoke into the sky. Inside these clouds, particles collide and generate static electricity, much like in a thunderstorm. The result is pyrocumulus clouds, storm clouds born from fire that can unleash their own lightning bolts back down onto the burning forest. These lightning strikes may ignite new fires, creating a cycle of flame feeding on itself. Firefighters sometimes witness skies flashing with lightning, even as flames roar below, an eerie union of fire and storm. This phenomenon shows that weather is not only a force upon landscapes, but also a force created by them. A burning forest becomes its own weather system, alive with thunder and fire, an intense reminder of nature's power to amplify itself in extraordinary ways. Smoke from fires can seed strange new clouds. When vast wildfires send smoke plumes high into the sky, they do more than darken the horizon. The tiny particles within smoke can act as nuclei around which water vapor condenses, forming clouds. Sometimes these clouds grow thick enough to cast wide shadows across the land, altering temperatures below. In extreme cases, smoke-driven clouds climb into the stratosphere, traveling thousands of miles. There, they may linger for weeks, subtly shifting weather patterns far from the original fire. The sight is haunting. Clouds with unusual hues, tinted orange or grey, glowing red in sunlight. Pilots have reported flying through smoky skies so dense, it feels like twilight at midday. These clouds are born not from the sea or sky, but from the flames of Earth itself, proof that fire and weather are intertwined, each capable of creating and shaping the other in unexpected ways. Dust from the Sahara Desert travels all the way to the Amazon. Every year, winds lift millions of tons of fine dust from the Sahara Desert, carrying it high into the atmosphere. These dust clouds cross the Atlantic Ocean, sometimes visible in satellite images as golden veils stretching for thousands of miles. Eventually, much of this dust falls onto the Amazon rainforest, where it delivers essential nutrients, particularly phosphorus, that enrich the soil. Without this transoceanic journey, parts of the Amazon might struggle to sustain its incredible biodiversity. The idea that one of the driest places on Earth helps feed one of the wettest and most lush is a powerful reminder of planetary interconnectedness. Even the air is a conveyor belt, linking desert and jungle in an unseen exchange. When you breathe in air touched by distant lands, you may be inhaling the fine dust of ancient dunes carried across oceans to sustain life in another hemisphere. Hurricanes can churn the sea until it glows with plankton light. Hurricanes are famous for their destructive winds and rain, but beneath the waves, they stir another wonder. As the massive storm churns the ocean, it stirs plankton, microscopic organisms that sometimes glow when disturbed. Sailors have reported sailing through seas illuminated with a ghostly blue light during storms, the surface glowing as though alive. This bioluminescence is created by chemical reactions inside the plankton, a defense mechanism triggered by turbulence. Though invisible from satellites, for those who witness it, the sight is unforgettable. A hurricane not only roaring above, but painting the sea with light below. These glowing oceans remind us that weather touches every layer of the planet, from the atmosphere to the deepest waters. Even in destruction, storms create moments of strange beauty, where life itself responds to the violence of wind and wave with flashes of living fire. Weather helps carve mountains into valleys. Mountains may seem eternal, but weather is always working to reshape them. Rain seeps into cracks, freezing and thawing, breaking rock apart. Wind scours exposed cliffs, tearing away grains of sand. Rivers slice into the slopes, cutting deep valleys and canyons. Over millions of years, even the mightiest peaks are worn down, their sharp edges softened, their summits lowered. The Himalayas and Rockies are still rising from tectonic forces, but weather battles them with relentless patience. Every landslide, every rockfall, every rushing stream is part of the quiet chiseling of the atmosphere. Without weather's erosion, Earth would be a harsher, sharper place. Instead, it is weather that sculpts the rounded hills, fertile valleys, and winding rivers we know. When you stand in a canyon or gaze at a mountain's worn face, you are seeing weather's artwork, etched in stone across the ages. Wind can sculpt stone into arches and spires. In deserts around the world, strange shapes rise from the ground, arches, spires, and mushroom-like rocks that seem almost alien. These are the sculptures of wind. Carrying sand like a natural sandblaster, the wind carves into rock over centuries, eroding soft layers while leaving harder ones behind. Some formations stand like towering pillars. Others curve into perfect arches, framing the sky. Monument Valley in the United States, the stone arches of Utah, and the wind-sculpted pinnacles of the Sahara are all products of this ceaseless work. Though the wind may feel gentle on your skin, over time it has the strength to carve landscapes that seem designed by an artist's hand. To walk among these formations is to wander through a gallery of natural sculptures, each shaped not by chisels, but by invisible currents of air moving grain by grain across stone. Lightning strikes can turn sand into glass. When lightning hits sandy soil, its immense heat can melt grains of quartz into glass. The strike fuses the sand into hollow, branching structures called fulgurites, which resemble frozen lightning in solid form. These fragile tubes can stretch for several feet underground, their surfaces rippled and glossy from molten minerals. Each one is a record of a single lightning strike, a signature of fire etched into the earth. Fulgurites are rare treasures for collectors and geologists, each piece a natural sculpture born in an instant of ferocious energy. Holding one is like holding a fossil of lightning, proof that the sky can transform stone in the blink of an eye. The next time you see lightning fork across the sky, imagine that beneath the ground, it may be leaving behind glassy tunnels, reminders of the storm's brief but extraordinary touch upon the earth. Glaciers move like rivers of ice, reshaping continents. To the eye, glaciers seem motionless, frozen rivers stretching through valleys. But they are always moving, flowing at speeds that can range from a few centimeters to several meters per day. Over centuries, their slow but relentless motion carves landscapes on a colossal scale. They grind mountains into U-shaped valleys, drag boulders for miles, and polish rock into smooth plains. During the last ice age, glaciers covered much of North America and Europe, reshaping entire continents as they advanced and retreated. Today, their remnants remain in Greenland, Antarctica, and high mountain ranges, still sculpting the land. To stand near one is to feel the weight of time itself, a river not of water, but of solid ice, moving with patient strength. Glaciers are living landscapes, slow, unstoppable, and transformative, whispering of ancient winters and the power of weather frozen into motion. Avalanches can move faster than cars on a highway. High in snowy mountains, a fragile balance often exists between slope and snow. When that balance breaks, an avalanche can begin. What starts as a small slide quickly accelerates, gathering snow, ice, and debris into a roaring torrent. Avalanches can reach speeds of over 80 miles per hour, faster than cars on a highway, and with the crushing power to sweep away forests, buildings, and roads. The sound is like thunder rolling down a mountainside, unstoppable once begun. For skiers and climbers, avalanches are a constant danger, triggered by weather, weight, or even a single footstep. Yet they are also part of the mountain's natural cycle, redistributing snow, shaping slopes, and feeding valleys below. Watching one from a safe distance is to witness nature's sudden fury, a reminder that snow is not always gentle, but can transform into a surging river of destruction in seconds. Icebergs hide nearly 90% of their mass underwater. The phrase, "tip of the iceberg," comes from a striking truth. What we see above the surface is only a fraction of what lies below. Icebergs broken from glaciers or ice shelves float in the ocean with most of their bulk hidden beneath the waves. Only about 10% is visible, while the rest lurks underwater, vast and invisible. This hidden mass makes icebergs dangerous for ships, as the Titanic tragically proved. Some icebergs are small, but others are massive, taller than skyscrapers and stretching miles in length. As they drift, they release fresh water into the sea, subtly altering ocean currents and ecosystems. The idea that something so immense can float silently, mostly unseen, captures the imagination. Icebergs are monuments of frozen time, slowly melting into the ocean, their true size revealed only to the deep waters that cradle them. Permafrost locks away ancient life forms. In the frozen soils of the Arctic and Siberia lies permafrost, ground that has remained frozen for thousands of years. Trapped within it are seeds, microbes, and even the remains of long-extinct animals like mammoths. As long as the permafrost stays frozen, these remnants remain preserved, sealed away in Earth's freezer. But when it thaws, ancient secrets awaken. Scientists have revived seeds tens of thousands of years old, and even microbes that had been dormant for millennia. Thawing permafrost also releases methane and carbon dioxide, gases that can affect global climate. To touch permafrost is to touch time itself, a layer of soil that bridges the living present and the frozen past. Beneath your feet may lie not just ice and dirt, but echoes of worlds long gone, locked away until weather and warming air decide to release them once more. Glacial meltwater can create rivers that roar under the ice. Though glaciers seem solid and silent, they are riddled with hidden rivers. As the sun warms their surfaces, meltwater seeps into cracks and tunnels, plunging deep into the ice. There, it gathers into roaring streams that carve channels beneath the glacier, echoing like subterranean thunder. These rivers can grow powerful enough to lift the glacier itself slightly off the ground, lubricating its movement. Sometimes, meltwater bursts suddenly from beneath, flooding valleys in what are called Yerkolapse, glacial outburst floods. To walk on a glacier, unaware of the torrents rushing just beneath, is to stand atop a living, breathing system, one where water and ice are constantly in conversation. These hidden rivers remind us that glaciers are not inert blocks, but dynamic landscapes, alive with the pulse of weather and water flowing unseen beneath the frozen surface. Weather drives the migration of animals across continents. All over the world, animals move with the weather. Birds chase the warmth of the sun, whales follow shifting seas, and caribou cross tundras as the seasons turn. These migrations are among the most extraordinary spectacles in nature, and weather is the unseen compass guiding them. Winds carry monarch butterflies across thousands of miles, ocean currents steer schools of fish, and rainfall patterns dictate where herds can graze. Even small changes in weather can shift these vast movements, altering ancient routes. To watch a migration is to see weather translated into motion, storms, winds, and rains, woven into the very instincts of life. Without weather's cycles, the great migrations of Earth would not exist, and countless species would lose their way. Each journey is a moving story written in the air itself, whether guiding the travelers of land, sea, and sky. Monarch butterflies follow weather patterns for thousands of miles. Every autumn, millions of monarch butterflies embark on one of the longest migrations in the insect world, traveling up to 3,000 miles from Canada and the northern United States to forests in central B, Mexico. Their fragile wings carry them across plains, mountains, and even the Gulf of Mexico, guided in part by the sun, the magnetic field, and the weather. They ride tailwinds when possible, saving energy, and wait out storms when conditions are too fierce. Generations of monarchs complete this cycle, each one inheriting the journey from ancestors that never returned. The weather along their path determines their success. A strong storm can devastate a population, while favorable winds can speed them on their way. That such delicate creatures can cross a continent, carried and challenged by weather, is a breathtaking reminder of how the atmosphere we live in connects all forms of life. Birds ride invisible rivers of rising warm air. High above fields and forests, birds often soar without flapping their wings, circling gracefully as though suspended in invisible currents. These currents are thermals, rising columns of warm air created when the sun heats the ground unevenly. Birds, especially large ones like hawks, storks, and vultures, use them to travel vast distances with little effort. By finding one thermal after another, they can glide for hours, conserving energy on long migrations. From the ground, their circling patterns look lazy and serene, but in truth, they are navigating an invisible map of weather. Pilots of gliders also use these same thermals, soaring silently alongside birds. Thermals are a reminder that the atmosphere is not empty space, but a living landscape of rising and falling air. For those who can sense it, feathered or human, these invisible rivers become pathways across the sky. Locust swarms are guided by rainfall. For centuries, locust swarms have been feared for their ability to strip landscapes bare in hours. These insect armies, sometimes billions strong, can stretch for miles, darkening the sky as they pass. What triggers them is deeply tied to weather. Locusts thrive after periods of rainfall that transform deserts into green fields. With food abundant, their populations explode, and they shift into swarming mode. Winds and storms then carry them across continents, sometimes traveling hundreds of miles in a single day. Ancient records describe locust swarms as punishments from the gods, but we now know they are weather's offspring, born from cycles of drought and rain. To stand in the path of a swarm is to witness the atmosphere's influence made visible in countless wings. Each insect is small, but together, guided by weather, they become one of nature's most formidable forces. Coral reefs bleach when seas grow too hot. Coral reefs are among the most vibrant ecosystems on Earth, home to countless species of fish, invertebrates, and plants. Yet they are also fragile. Corals live in partnership with tiny algae called zooxanthellae, which provide them with both food and color. When ocean waters grow too warm, the corals expel these algae in distress, turning ghostly white, a phenomenon called bleaching. Without their algae partners, corals can starve, leaving behind lifeless skeletons where bustling reefs once thrived. Bleaching events have been increasing in recent decades, threatening reefs across the tropics. From space, satellites can even see these vast pale patches spreading across oceans. But corals are resilient when conditions improve, sometimes recovering after years of rest. Watching a reef bleach is like seeing a living rainbow fade to bone. It is a reminder of how intimately weather and climate tie to the health of even the ocean's smallest creatures. Weather shifts have ended entire civilizations. History is often told as a story of kings and wars. but weather has quietly shaped it from the beginning. Prolonged droughts have dried rivers that sustained cities, floods have swallowed farmland, and shifts in monsoons have starved empires. Archaeological evidence shows that entire civilizations, from the Akkadian Empire in Mesopotamia to the great cities of the Indus Valley, collapsed after sudden climate changes. Crops failed, trade routes withered, and people were forced to abandon homes built over centuries. Weather doesn't always destroy with storms or fire. Sometimes it unravels societies slowly, like a thread pulled from a tapestry. When we look at ruined temples or empty cities, we often see the fingerprints of climate. The rise and fall of civilizations is not just a story of human ambition, but of skies that gave or withheld, winds that shifted, and rains that never came. A single drought may have toppled the Mayan Empire. Deep in the jungles of Central America, the ancient Maya built soaring cities, observed the stars, and carved their histories into stone. But by the 9th century, many of their great cities were abandoned. What caused this collapse has been debated for years, and one of the strongest clues comes from weather. Sediment cores and cave formations show evidence of a prolonged drought lasting decades, with rainfall dropping sharply in the region. Without water, crops failed, conflicts grew, and populations dwindled. The mighty pyramids and ball courts fell silent, swallowed by jungle. The Maya people themselves survived, but their empire fractured and changed forever. The thought that shifts in weather, invisible winds and absent rains, could topple such a powerful culture is humbling. It is a reminder that human history is inseparable from climate, and that even the greatest cities depend on the sky. Ancient battles were won or lost because of storms. The outcome of wars has often hinged not on strategy alone, but on weather. In 1588, the Spanish Armada set sail to invade England, only to be scattered and sunk by fierce storms in the North Atlantic. Centuries earlier, Kublai Khan's fleets were destroyed by typhoons when he tried to invade Japan. Storms that the Japanese called kamikaze, or divine winds. Even in more recent times, mud, rain, and snow have stalled armies and reshaped campaigns. Napoleon's retreat from Russia was made catastrophic by brutal winter cold, while the D-Day landings of World War II succeeded only because meteorologists found a brief window of favorable morale. Weather. Storms do not take sides, but they have changed the course of history, deciding the fate of nations in ours. In the chaos of battle, the sky above is sometimes the most powerful commander of all. The Little Ice Age froze rivers in the heart of Europe. From the 14th to the 19th century, Earth passed through a period known as the Little Ice Age. Winters grew longer and harsher, glaciers advanced, and crops struggled in the cold. In Europe, the River Thames in London froze solid many times, thick enough to hold entire festivals upon its icy surface. Paintings from the time show frost fairs with tents, markets, and even ice skating on the frozen river. In the Netherlands, canals froze so often, but ice skating became woven into the culture. Though not a true ice age, the period was cold enough to leave its mark on art, food, and history. Volcanoes, changes in solar activity, and shifting ocean currents all played a role in this centuries-long chill. To imagine major rivers frozen into solid streets of ice is to glimpse how even modest changes in climate ripple through human lives. Cities create heat islands warmer than the countryside. Walk from a shaded park into a downtown call on a summer afternoon, and you may feel as though you've stepped into a hotter world. Cities absorb and trap heat more effectively than natural landscapes, creating what scientists call urban heat islands. Asphalt, concrete, and steel soak up the sun's energy during the day and release it slowly at night, keeping temperatures several degrees warmer than surrounding rural areas. Skyscrapers block wind, air conditioners vent hot air, and vehicle exhaust adds to the effect. These heat islands can make heat waves more dangerous, especially at night when cooling relief never comes. Solutions exist: planting trees, painting rooftops white, and creating green spaces all help. Still, the phenomenon shows how human design reshapes weather on a local scale. The city itself becomes a climate, a man-made oasis of heat glowing against the cooler countryside around it. Skyscrapers can bend and accelerate local winds. Stand at the base of a tall skyscraper, and you might notice the wind suddenly rushes harder. This effect is caused by the way tall buildings channel air. As wind meets a wall of glass and steel, it is forced downward and around the structure, creating gusts far stronger than in open areas. In some cities, these winds are powerful enough to knock over bicycles, flip umbrellas, and make walking difficult. Architects now design buildings with curved shapes or open sections to ease these urban gales, but they remain a striking example of how human structures interact with weather. From the top of a skyscraper, the winds may be steady and serene, but at street level, the air can swirl with surprising violence. The skyline is not just a backdrop. It reshapes the atmosphere itself, bending the invisible flow of air into new patterns. Air pollution can make sunsets burn redder. Sunsets are always beautiful, but sometimes they glow with an intensity that seems unreal. Blazing oranges, deep crimsons, and streaks of purple across the horizon. This spectacle can be caused by tiny particles in the atmosphere. Dust, smoke, or pollution scatter shorter wavelengths of light, letting only the deeper reds and oranges reach our eyes. After major volcanic eruptions, sunsets around the world have been described as fiery and surreal, painted by ash suspended high in the stratosphere. While pollution is harmful to health, it also demonstrates how small changes in the atmosphere can alter the canvas of the sky. Every sunset is a collaboration between sunlight and air, shaped by the particles drifting unseen above us. When you see a crimson horizon, you are looking not only at the sun's glow, but at the hidden fingerprints of weather and atmosphere painted into light. Clouds can be seeded with particles to make rain. In some regions desperate for water, humans have tried to coax clouds into giving up their rain. This process, called cloud seeding, involves releasing particles like silver iodide or dry ice into the sky. These particles act as nuclei around which water vapor condenses, helping droplets grow large enough to fall as rain. Cloud seeding has been attempted since the mid-20th century, with mixed results, sometimes increasing rainfall by a modest percentage. Planes, rockets, or even ground-based generators release the particles, turning weather into a field experiment. Though not a miracle solution, cloud seeding has been used in countries such as China, the United States, and the United Arab Emirates. The very idea that humans can nudge clouds into producing rain is a striking reminder of how we interact with weather. It is the atmosphere's own alchemy, harnessed by science in moments of need. Red skies in the evening often do predict the next day's weather. Red sky at night, sailors delight. Red sky in morning, sailors take warning. This old saying has roots in real atmospheric science. At sunset, a red sky often means that dry, dusty air is present to the west, where weather systems typically approach. This suggests stable conditions and fair weather ahead. A red sky at sunrise, however, may indicate that this same dry air has already passed, leaving unsettled weather to follow. The scattering of sunlight through particles and moisture paints the sky with crimson hues, a visible clue to the state of the atmosphere. Mariners, farmers, and shepherds once relied on such signs to guide their days, long before satellites and forecasts. While not always perfect, the rhyme carries wisdom tested over centuries. The colors of dawn and dusk are more than beauty. They are messages from the sky, ancient forecasts painted in light. A rainbow is a circle. We usually see only half. From the ground, rainbows appear as graceful arcs across the sky, but in truth, they are full circles of light. We usually see only the top half because the horizon blocks the rest. Pilots, however, sometimes report seeing complete circular rainbows when looking down on storms from above. Each rainbow forms when sunlight enters raindrops, bends, reflects off the inner surface, and bends again as it leaves. This bending splits light into its spectrum of colors, fanning them into a circle of brilliance. The size of the circle depends on the angle of the sun, but it always exists in full. To realize that the rainbow we see is just a partial glimpse adds a hidden layer of wonder. What feels like an arc above us is actually a complete wheel of color, a perfect circle of light written into falling rain. Double rainbows reveal light's hidden paths. Sometimes, if conditions are just right, a rainbow appears with a fainter twin above it. This double rainbow is created when sunlight reflects twice inside raindrops instead of once. The second reflection sends light back at a different angle, forming the outer arc. In this secondary rainbow, the colors are reversed. Red appears on the inside and violet on the outside. The space between the two rainbows, called Alexander's band, often looks darker because less light reaches it. Double rainbows are not rare, but they always feel magical, filling the sky with twin arcs of color. Poets and artists have celebrated them for centuries, while scientists see them as elegant demonstrations of optics in action. Each rainbow is already a wonder, but when two appear, it feels as though the sky is revealing secret layers of its light, doubling the beauty of the storm's afterglow. Sundogs sparkle like extra suns on icy days. On very cold days, when ice crystals drift high in the atmosphere, strange companions may appear beside the sun. These are sundogs, bright spots of light that sparkle on either side of the sun like phantom stars. They form when sunlight bends through hexagonal ice crystals in cirrus clouds, splitting into colors similar to a rainbow. Sometimes they glow faintly, like halos, and other times they blaze brilliantly, creating the illusion of three suns shining in the sky. Sundogs are best seen when the sun is low on the horizon, often during sunrise or sunset in winter. For ancient peoples, they were omens, signs of power or mystery in the heavens. For us, They are dazzling demonstrations of how ordinary light interacts with the icy breath of the atmosphere. To see a sundog is to glimpse the hidden artistry of sunlight painted on cold skies. Halos appear when sunlight bends through crystal clouds. Look up on a frosty day, and you may see a ring of light encircling the sun or the moon. This is a halo, formed when light passes through countless tiny ice crystals floating in high, thin clouds. The crystals bend the light at precise angles, creating a glowing circle around the sky's brightest object. Halos often signal that a weather front is approaching, as the cirrus clouds that create them are the first signs of changing conditions. They can shimmer in pure white or show faint rainbow colors along their edges. Moon halos glowing at night feel especially ethereal, pale rings floating against the darkness. These simple shapes are products of countless crystals drifting silently, each bending light in the same way. A halo is both a forecast and a work of skyborne geometry, a quiet message from the atmosphere etched in light. Mirages can make whole lakes appear where none exist. On hot summer days, desert travelers and highway drivers alike may glimpse shimmering pools of water on the horizon. Walk closer, and the water vanishes, a mirage. This illusion happens when layers of hot air near the ground bend light upward. Instead of coming straight to your eyes, light from the sky curves, creating the appearance of water reflecting above. These optical tricks can be so convincing that ancient travelers chased them, only to find more sand instead of relief. Even today, mirages can trick the eye into seeing floating ships, distant lakes, or distortions in the road ahead. They remind us that what we see is not always reality, but the atmosphere's playful bending of light. In their fleeting shimmer, mirages are weather's illusions, blending physics and art into visions that dissolve as quickly as they appear. Superior mirages can make ships float in the sky. In polar regions and over cold seas, another kind of mirage can appear, one stranger still. Called a superior mirage, it happens when layers of cold and warm air bend light downward, making distant objects appear higher than they really are. Ships beyond the horizon may seem to float in the air, castles may hover above the waves, and coastlines can appear doubled or stretched. Sailors once told stories of ghostly fleets suspended above the ocean, their masts rising into the sky. This bending of light can create shapes so surreal that they inspired myths of phantom lands. Though the explanation is scientific, the effect is no less magical. A superior mirage is a reminder that the atmosphere is a lens, constantly shaping what we see. It can turn the ordinary into the extraordinary, ships sailing not on water, but across the sky itself. The green flasher appears for seconds at sunset. At the precise moment the sun slips below the horizon, some observers glimpse a fleeting emerald sparkle, the green flash. This rare phenomenon occurs because the atmosphere bends light into its spectrum. Blue and violet scatter away, red passes straight through, but green lingers just long enough to flare before the sun disappears. It lasts only seconds, and you must be watching carefully to catch it, usually over the sea where the horizon is clear. For centuries, sailors and poets treated it as a sign of luck or mystery. Scientists now understand it as optics, but that doesn't lessen its wonder. To see a green flash is to witness a secret of the sky, a final flourish of color, hidden in the sunset's fade. Few have seen it with their own eyes, but those who have never forget that moment of sudden green fire. Moonbows glow faintly under a full moon. Rainbows are common after storms, but under the light of the full moon, the same effect can occur on a far subtler scale. Moonbows, or lunar rainbows, are arcs of pale light formed when moonlight bends through raindrops at night. Because moonlight is much weaker than sunlight, moonbows usually appear white to the naked eye, their colors too faint for our eyes to distinguish. With long exposure photography, however, their soft spectrum is revealed. To see a moonbow is rare. The conditions must be perfect, with rain on one side of the sky and a bright full moon low on the other. In folklore, moonbows were considered magical, glowing bridges in the night. They remain among the most delicate spectacles of weather, a quiet echo of rainbows that feels more like a dream than reality. A rainbow painted not by the sun, but by the moon's silver glow. Lightning can strike the same place more than a dozen times. There's a common myth that lightning never strikes the same place twice, but the truth is the opposite. Lightning often favors tall, conductive objects, returning to them again and again. The Empire State Building in New York is struck about 25 times each year. Television towers, mountain peaks, and even lone trees in open fields can be hit repeatedly during a single storm. This happens because these objects act as pathways, helping the electrical charge leap from sky to ground. Lightning is not random chaos. It follows the rules of physics, seeking the easiest route. Knowing this helps engineers design lightning rods to protect buildings by attracting strikes safely. So while lightning may seem unpredictable, it is also strangely loyal, returning to familiar places time after time, leaving behind its fiery signature in the same spots again and again. Ball lightning has been seen glowing inside airplanes. Among the strangest and most mysterious weather phenomena is ball lightning, glowing orbs of light, but sometimes appear during thunderstorms. Witnesses describe them as spheres ranging from a few centimeters to several meters across, glowing white, yellow, or even blue. They drift slowly, sometimes hovering, sometimes darting unpredictably, and often vanish with a bang or a hiss. One of the most astonishing reports came from an airplane in the 1960s, where passengers saw a ball of light drift down the aisle before disappearing. Scientists still do not fully understand what ball lightning is, whether it's plasma, burning vapor, or something else entirely. It is so rare that many scientists once doubted its existence. But too many accounts from pilots, sailors, and storm watchers confirm its reality. Ball lightning remains one of the atmosphere's great mysteries, a ghostly fire wandering briefly before fading back into the storm. Sprites flash red high above thunderclouds. Most lightning strikes downward, flashing between storm clouds and the ground. But high above the thunderheads, strange and fleeting lights sometimes appear. Sprites. These are vast bursts of reddish light, stretching up into the upper atmosphere like ghostly jellyfish. They occur when strong lightning discharges disturb the air's electric field, sending energy upward instead of down. Sprites can span tens of miles in height, but they last for only milliseconds, so quick that the naked eye often misses them. Pilots at cruising altitude sometimes glimpse them dancing above distant storms, and modern cameras have captured their eerie beauty. Sprites remind us that storms are not confined to the clouds we see. They reach upward into the edge of space, painting the thin air with fiery red strokes. To imagine a thunderstorm glowing not only below but also above is to realize how alive the sky truly is. Blue jets shoot lightning upward into space. While sprites glow red, their cousins, called blue jets, flash in the opposite direction, shooting upward from thunderclouds into the stratosphere. They appear as narrow cones of blue light, piercing toward the edge of space. Though jets are rare and difficult to study, but astronauts aboard the International Space Station have witnessed them firsthand, describing luminous spears rising from storms below. Scientists believe they form when electrical charges build up at the tops of clouds and release into the thin upper air. Unlike ordinary lightning, which strikes the ground, blue jets are lightning's skyward escape. They reveal that storms are not isolated events, but part of a larger atmospheric circuit stretching from the surface to the heavens. To think of lightning reaching for the stars rather than the Earth is to glimpse the secret pathways of electricity hidden in the highest layers of our atmosphere. Volcanoes can unleash storms of electric fire. During a volcanic eruption, the Earth itself seems to roar, spitting lava, ash, and smoke into the sky. But within these clouds of ash, something even stranger happens: volcanic lightning. As ash particles collide and rub together, they generate static charges, much like ice crystals in thunderstorms. Bolts of lightning then erupt within the dark plume, crackling across the night sky. These volcanic storms can be so intense that entire skies glow with electric fire, illuminating landscapes with eerie brilliance. Witnesses describe the spectacle as apocalyptic, the mountains spewing flame below, the heavens tearing with light above. Scientists study these storms to better understand how lightning forms, but for those who see it in person, no explanation is needed to feel the awe. Volcanic lightning is nature's double storm, fire and electricity joined, a reminder that Earth's weather is as fierce beneath as it is above. The most powerful storm ever measured was on Earth. Though other planets host immense tempests, Earth itself has produced storms of staggering force. The title of the most intense tropical cyclone belongs to Typhoon Tip in 1979. At its peak, it stretched more than 1,300 miles across, nearly half the width of the United States. Its central pressure dropped lower than any other measured storm, a sign of its immense strength. Winds howled at speeds exceeding 190 miles per hour, while torrential rains flooded entire regions. From satellites, Tip appeared as a perfect spiral, a monstrous pinwheel covering the western Pacific. Though it eventually weakened before landfall, its sheer size and intensity remain unmatched. To imagine a single storm large enough to blanket continents is humbling. Even here on Earth, where we think we know the atmosphere well, the sky still proves capable of conjuring storms of truly unimaginable scale. Jupiter's great red spot has raged for centuries without end. If you peer through a telescope at Jupiter, you'll see a vast oval swirling in its southern hemisphere, the Great Red Spot. This is no ordinary storm, but a colossal cyclone wider than Earth itself, spinning for at least 300 years, and likely much longer. Its winds reach over 400 miles per hour, churning ammonia clouds into crimson and beige bands. Unlike hurricanes on Earth, which fade in days or weeks, the red spot endures, fueled by Jupiter's immense atmosphere and energy. It has changed over time, shrinking slightly, its colors shifting, but it continues to spin, a symbol of planetary fury. Astronomers track it like a living creature, a storm that has outlasted generations of observers. To think of a storm that began before telescopes were common and still rages today is to feel the scale of time and weather beyond our world. Saturn's hexagonal storm spins perfectly around its pole. Saturn hides one of the strangest weather phenomena in the solar system, a giant, six-sided storm encircling its north pole. This hexagon is larger than Earth, a swirling jet stream locked into a perfect geometric shape. First discovered by the Voyager spacecraft in the 1980s, it has persisted for decades, spinning like a celestial kaleidoscope. Scientists believe that differences in wind speed create standing waves in the atmosphere, sculpting the storm into its bizarre polygon. From above, the hexagon looks unreal, as though drawn by some cosmic artist rather than shaped by nature. Within it, smaller storms rage, while the hexagon itself rotates steadily. No other planet shows a storm quite like this. Saturn's hexagon is a reminder that weather is not always chaotic and shapeless. Sometimes, it forms patterns of surprising elegance, carving order into the endless turbulence of planetary skies. Uranus has winds faster than sound on Earth. Distant Uranus may appear calm, a pale blue-green sphere in the outer solar system. But beneath its tranquil appearance lurk some of the fastest winds ever measured. Jet streams race around the planet at speeds of up to 1,200 miles per hour, faster than the speed of sound on Earth. These winds whip through an atmosphere of hydrogen, helium, and methane, sculpting faint cloud bands barely visible through telescopes. Scientists are still unsure why Uranus spins such fierce gales. Its tilted axis, unusual interior, and distant orbit all play a role in its mysterious weather. From Earth, we see only a serene disk. But up close, Uranus is anything but calm. It is a world of supersonic winds, where storms rage in silence across a frozen giant, reminding us that appearances can be deceiving. Even a quiet-looking planet can roar. Neptune's dark storms are supersonic hurricanes. Neptune, the farthest planet from the Sun, is home to some of the most violent weather in the solar system. In 1989, the Voyager 2 spacecraft captured images of a massive dark storm swirling across its surface, similar to Jupiter's Great Red Spot. These storms, known as Great Dark Spots, are immense hurricanes with winds reaching 1,300 miles per hour, the fastest winds ever recorded on any planet. They can span thousands of miles and last for years before disappearing and reforming elsewhere. The planet's cold atmosphere, rich in methane, gives these storms their deep blue and shadowy appearance. Despite the distance, Neptune's storms reveal themselves as dynamic, shifting systems, alive with ferocity even in the dim sunlight at the edge of the solar system. To imagine standing there, in winds faster than bullets, is to glimpse weather at its most extreme, alien and wild. Some exoplanets may rain glass sideways. Among the thousands of exoplanets discovered, some defy all imagination. On one distant planet, astronomers believe the skies are filled with silicate particles, tiny grains of glass. Winds on this planet scream at over 4,000 miles per hour, strong enough to hurl these shards sideways across the atmosphere. The result is a storm unlike anything on Earth. Glass rain blowing horizontally at supersonic speeds. Observed through the dimming of starlight as the planet passes its star, the data suggests an environment both beautiful and lethal, with blue clouds reflecting a dazzling hue. To picture a place where the rain cuts instead of nourishes is to see how alien weather can become. Compared to this, Earth's fiercest storms feel tame. Exoplanets remind us that our own weather is just one version of the possibilities written in the skies of countless worlds. Others may have clouds made of molten iron. If glass rain seems otherworldly, consider the planets hot enough to vaporize metals. On worlds that orbit dangerously close to their stars, temperatures soar beyond 2,000 degrees Celsius. In such places, clouds may fall not from water vapor, but from vaporized metals like iron. When conditions shift, this iron condenses and falls as metallic rain. Imagine standing in a storm where droplets of molten iron sizzle as they strike the ground, glowing briefly before cooling into solid metal. These environments, though uninhabitable, stretch the imagination of what weather can be. Each discovery broadens our sense of the possible, revealing that the familiar cycle of evaporation and rain on Earth is only one expression of a universal pattern. On distant worlds, weather writes itself in the language of fire and metal, strange and dazzling, yet born of the same physics that govern our gentle clouds. Earth's atmosphere once glowed orange after its birth. Billions of years ago, Earth's early skies were not the blue we know today. The young planet's atmosphere was filled with gases from volcanic eruptions, carbon dioxide, methane, ammonia, and nitrogen. Without oxygen, the air glowed a hazy orange under the faint sun, shrouding the surface in a dim, alien light. The seas bubbled with chemical reactions, and the first forms of life emerged under this strange sky. Over time, photosynthetic microbes began releasing oxygen, slowly transforming the atmosphere. The haze cleared, the sky turned blue, and the ozone layer formed, shielding life from harmful radiation. To imagine Earth beneath an orange sky is to glimpse a planet in transition, a world before forests, oceans teeming with fish, or clouds as we know them. Our atmosphere has not always been what it is today. It has changed dramatically, carrying the story of life itself. Ancient ice holds tiny samples of prehistoric air. Deep within glaciers and ice sheets, bubbles of air are trapped, sealed away for tens of thousands of years. When scientists drill ice cores from Antarctica or Greenland, they are not just extracting frozen water, they are retrieving time capsules. Each layer of ice holds a record of the atmosphere from the year it formed. Within those bubbles lies the air our ancestors once breathed, untouched for millennia. By studying these ancient samples, scientists reconstruct Earth's climate history, tracking shifts in carbon dioxide, oxygen, and methane over hundreds of thousands of years. These records reveal cycles of ice ages and warming, showing how closely weather and climate have danced with life. To hold a fragment of ancient ice is to cradle Earth's breath from long ago, a whisper of prehistoric skies preserved in crystal, waiting to tell the story of ages past. The carbon cycle is deeply tied to weather. Every breath we take, every storm that falls, and every gust of wind is linked to the carbon cycle, the constant movement of carbon through air, land, ocean, and life. Plants draw carbon dioxide from the atmosphere, locking it into leaves and wood. Animals eat, exhale, and return it. Oceans absorb vast amounts of carbon, storing it in shells, sediments, and deep waters. Volcanic eruptions release it, while weathering rocks slowly pull it back in. Weather acts as both a driver and a messenger of this cycle. Rains wash carbon into rivers, storms stir it into the sea, and seasonal winds determine how much plants breathe in. The balance of carbon shapes Earth's temperature and climate. To see the cycle clearly is to realize that weather is not just the mood of the day, it is part of the heartbeat of the planet itself. Clouds both warm and cool the planet. Clouds are some of the most familiar features of the sky, yet they hold immense power over Earth's climate. By day, they reflect sunlight back into space, cooling the surface below. By night, they trap heat, acting like a blanket that keeps warmth from escaping. The balance of these two effects determines whether clouds warm or cool a region, and scientists are still studying which influence dominates globally. Different types of clouds play different roles. Bright, low clouds tend to cool, while high, thin cirrus clouds can trap heat more effectively. Without clouds, Earth would be far hotter during the day and much colder at night. They are weather's regulators, shaping both the immediate mood of the sky and the long-term balance of the climate. Each drifting cloud is more than vapor. It is a guardian of temperature, a soft, shifting shield above our world. Melting sea ice changes wind and ocean patterns. In the Arctic, sea ice forms a bright cap that reflects sunlight back into space. As the climate warms and ice melts, darker ocean water is exposed, absorbing more heat. This change ripples outward, altering winds, currents, and even distant weather patterns. With less ice, the atmosphere shifts, sometimes pushing cold Arctic air farther south in winter or changing rainfall patterns elsewhere. The melting also disrupts ecosystems, affecting animals like polar bears and seals that depend on ice to survive. Sea ice is not just frozen water, it is a critical part of Earth's climate engine. Its annual rhythm of growth and melt helps drive circulation in both ocean and sky. Watching it retreat is like watching a gear in the planet's machinery slow down, changing the way the entire system moves. Weather everywhere feels its touch, even far from the poles. Climate change is making extreme weather more common. Around the world, scientists are observing a trend. Extreme weather events are growing more frequent and intense. Heat waves stretch longer, wildfires spread farther, hurricanes grow stronger, and floods strike harder. The warming of Earth's atmosphere loads the dice, making certain events more likely. Warmer air holds more moisture, fueling heavier rains, while hotter sees energized tropical storms. These changes are not abstract. They affect daily life, agriculture, health, and safety. Yet they also highlight the interconnectedness of climate and weather. What happens in the atmosphere is tied to choices we make on the ground. Understanding this connection allows us to prepare, adapt, and mitigate. Extreme weather is not just a natural force. It is increasingly shaped by human influence. The storms, droughts, and floods we face today are part of a story in which we ourselves play a role. Storm surges are rising with the seas. When a hurricane or typhoon makes landfall, one of its deadliest features is not the wind, but the storm surge, the wall of ocean water pushed ashore by the storm. These surges can rise several meters, flooding coastal cities and sweeping away homes. As sea levels rise with climate change, storm surges begin from a higher baseline, making them more destructive. Areas that once experienced only rare flooding may now face it with increasing regularity. From above, a storm surge looks like the sea itself, rising against the land, erasing coastlines. For people living near the ocean, it is one of the most immediate reminders of how climate and weather intersect. The surge is not just a wave, it is the atmosphere's power translated into the language of the sea, crashing into human shores with unstoppable force. Heat waves are growing hotter and longer. Heat has always been part of weather's cycle, but in recent decades, heat waves have become more severe. Across continents, records are being broken, not just by a degree or two, but by margins that were once unimaginable. Nights, which normally bring relief, now stay sweltering, trapping heat in cities. Crops wilt in fields, reservoirs shrink, and power grids strain as people seek cooling. Heat waves kill more people worldwide than any other form of extreme weather, their effects quiet but devastating. Scientists tie their growing intensity to the warming climate, which shifts baselines higher and makes extremes more likely. For those experiencing them, heat waves are a reminder that weather is not always dramatic thunder or rain. Sometimes it is simply still, oppressive air, a relentless warmth that seeps into every corner. And increasingly, these waves of heat define summers across the globe. Rainfall is shifting into new global patterns. The rhythm of rainfall defines life on Earth. Monsoons, seasonal storms, and steady showers sustain crops, forests, and rivers. Yet as the climate changes, these patterns are shifting. Some regions are seeing heavier downpours, while others are enduring longer droughts. Storm tracks drift, dry zones expand, and places once fertile become arid. For communities that depend on predictable rains, these changes bring uncertainty and struggle. Satellites now track rainfall across the globe, showing how belts of moisture are moving, reshaping entire landscapes. It is as though the planet is redrawing its map of wet and dry. The air still holds water, clouds still form, but where and when they release their bounty is changing. This global reshuffling of rain is one of the quiet revolutions of weather, altering the course of rivers, the spread of deserts, and the balance of life itself. Lightning strikes may increase as the climate warms. Thunderstorms are fueled by heat and moisture, and as the world warms, both ingredients become more abundant. Some studies suggest that this could lead to more frequent lightning strikes in the decades ahead. More lightning means more wildfires, more ozone formation in the atmosphere, and more hazards for people and animals. Already, satellites track millions of lightning bolts each year, mapping their shifting patterns. While predictions are complex, the link between warming and lightning is a vivid reminder of how even small changes in temperature ripple outward into storm behavior. Each flash of lightning is a sudden release of energy, born from the atmosphere's restless churn. As Earth grows hotter, the sparks of its storms may multiply, filling the skies with more of nature's electric fire. The stormy future may be one where the heavens blaze more often than ever before. Hurricanes are expected to grow stronger in the future. As oceans warm, hurricanes draw more fuel from the heat stored in the water. A storm that might once have been moderate can now grow into a monster, its winds accelerating, its rains intensifying, and its surge climbing higher against the coast. Scientists already see this trend. Fewer but stronger storms, reaching categories 4 and 5 more often. Satellites capture them from above, their spirals vast and mesmerizing, while on the ground, people face winds that sound like jet engines and seas that rise like walls. These future storms will not only be natural events, but stories of resilience, adaptation, and preparation. To imagine stronger hurricanes ahead is both sobering and awe-inspiring, the atmosphere sharpening its edge as it reflects the warmth we add to the planet. They are reminders that weather is alive, restless, and always ready to show its full force. Floods and droughts may alternate more often. Across the world, people are beginning to notice a new rhythm. Long, dry stretches followed by sudden torrents of rain. This alternating pattern is tied to a warming atmosphere which can hold more water vapor. Dry spells become more parched, while storms dump more water in a short time, overwhelming rivers and soils. Crops may suffer both thirst and drowning in the same season. These swings between extremes can reshape landscapes, carving new river channels and leaving cracked deserts in their wake. To witness such contrast is to see the atmosphere pulling harder on both ends of its spectrum. Floods and droughts have always been part of weather's cycle, but now they arrive more fiercely, often in the same regions within the same years. It is as if the sky itself cannot decide, giving nothing, then giving everything all at once. Weather satellites now cover the entire planet. High above Earth, an invisible fleet of satellites orbits silently, watching the atmosphere. They track cloud movements, measure temperatures, scan moisture, and even peer into the heart of storms. Every few minutes they send streams of data back to Earth, where scientists weave it into forecasts. From these watchful eyes, no corner of the planet is unseen. Hurricanes swirling over oceans, sandstorms sweeping across deserts, or even the subtle rise of water vapor before a storm forms. These satellites have transformed forecasting, allowing us to predict disasters days earlier and save countless lives. But they also provide beauty, images of Earth's weather as shimmering mosaics of color and motion. To know that above us, machines keep constant vigil, turning the chaos of the atmosphere into patterns we can study, is to realize how far we've come in learning to read the language of the sky. Supercomputers can model storms days before they form. Inside vast halls cooled by fans, supercomputers hum like giant brains, running calculations billions of times each second. With this power, scientists feed in satellite data, sea surface temperatures, and atmospheric conditions to simulate the weather. These models can spin up hurricanes in digital oceans days before they form in reality, predicting their paths, strength, and rainfall. Each run of the model is like a rehearsal of the future, with the atmosphere playing out its possible moves. Though imperfect, these simulations are stunningly powerful, giving communities time to prepare for storms or heat waves that once struck without warning. It is a kind of time travel, glimpsing the weather of tomorrow through mathematics today. To think that invisible equations, crunched at lightning speed, can whisper to us what clouds, winds, and rains will soon decide is to marvel at how science has learned to dream with the sky. Forecasts today are more accurate than ever in history. Not long ago, predicting the weather was little more than guesswork. Farmers relied on sayings, sailors on the color of the sky, and townsfolk on the feel of the air. But today, forecasts are astonishingly precise. We can track storms across oceans, predict rainfall down to the hour, and even issue warnings for tornadoes minutes before they touch down. What once seemed like fortune-telling is now rooted in physics, satellites, and models that digest billions of data points. While we still complain when rain ruins a picnic, it is worth remembering how miraculous it is that we can know the moods of the atmosphere days ahead. Forecasts are humanity's partnership with the sky. Imperfect, yes, but profoundly more accurate than at any time in history. In them, we see how far our understanding of weather has come and how far it may still go. Still, the chaos of weather makes it impossible to predict perfectly. For all our satellites, supercomputers, and models, weather remains a master of surprise. The atmosphere is a chaotic system, exquisitely sensitive to the smallest changes. A shift in wind, a patch of warm sea, or a sudden burst of convection can alter the path of storms, ripple patterns of rainfall, or scatter clouds unexpectedly. This sensitivity is what makes long-term forecasts so difficult. Beyond a week or two, the atmosphere veers into uncertainty as countless tiny variables multiply. It is sometimes called the butterfly effect, the idea that even the smallest flutter can tip the balance of weather. This unpredictability is not a flaw, but a truth of nature. The sky holds mysteries we may never solve completely. To know this is to embrace weather not just as science, but as wonder. A reminder that some rhythms of Earth will always keep their secrets. Animals can often sense storms before humans do. Long before meteorology, animals listen to the sky in ways we barely understand. Birds may flee before a storm arrives, sensing shifts in pressure or the low rumbles of distant thunder. Cows and horses sometimes grow restless as air grows heavy, while dogs and cats hide. Their ears are tuned to sounds beyond our hearing. Even insects can react, with bees returning to hives and ants sealing their tunnels before rain. Scientists have measured that many animals detect barometric pressure changes far more acutely than we can. In the past, farmers relied on these subtle cues, watching flocks and herds for signs of what the sky was preparing. Today, while satellites scan the atmosphere, animals remain the oldest forecasters, instinctive, sensitive, and tuned to whispers of the weather. Their awareness reminds us that forecasting is not only high-tech, but also deeply woven into life itself. Your joints may ache when pressure drops. Many people notice an ache in their knees, shoulders, or hands just before a storm. This is no illusion. Changes in barometric pressure, the weight of the air pressing down on us, can affect tissues in the body. As pressure drops ahead of a storm, fluids in joints may shift slightly, irritating sensitive nerves and inflamed areas. For those with arthritis, this can bring aches or stiffness that feel like a built-in forecast. Though not everyone is sensitive, enough people experience it that doctors take it seriously. The human body, it seems, is another kind of weather station, registering shifts in the invisible atmosphere. It is remarkable to think that the same pressure changes that drive clouds and winds also resonate within our bodies. When the sky prepares for rain, sometimes our bones remember first, aching with the echo of approaching storms. The sky can turn green before a tornado forms. In the moments before severe thunderstorms unleash their power, the sky sometimes glows an eerie green. This unsettling hue occurs when sunlight filters through towering storm clouds heavy with rain and hail, scattering light in a way that amplifies green wavelengths. For meteorologists, it can be a warning sign that a storm is strong enough to produce hail and possibly tornadoes. For those who witness it, the green sky feels otherworldly, like a veil of color stretched across the horizon. Storm chasers describe it as a chilling calm before chaos, the atmosphere glowing with its own signal of danger. Though the science behind it is understood, the sight is no less haunting. A green sky is weather's warning light, a surreal reminder that something powerful is brewing just beyond the clouds, ready to descend upon the earth with sudden fury. Weather is Earth's heartbeat, always shifting, never still. Beneath the blue dome of our sky, weather is in constant motion. Winds turn, clouds form and dissolve, rains fall, and sunlight breaks through again. Every gust, every drop, every shimmer of light is part of a living system, restless and endlessly renewing. To watch the sky is to feel the pulse of the planet, sometimes gentle, sometimes wild, but always present. Weather is not just a backdrop to our lives. It is the rhythm that sustains oceans, forests, and fields. It is the force that shapes civilizations, tells stories in rainbows, and whispers through the quiet drift of snow. To call it Earth's heartbeat is no metaphor. It is the pulse of air and water, the circulation of energy that makes our world alive. And though we can measure, predict, and model, we are always passengers beneath its ever-changing song. And so, our journey through the endless sky draws to a close. We have drifted through storms and sunlight, through clouds that weigh as much as mountains and raindrops shaped by unseen forces. We have wandered across deserts where rain never falls, into the frozen heart of glaciers, and upward into the strange glow of sprites and sundogs. Together we have seen that weather is not just the backdrop to our days, it is a living rhythm, shaping land, life, and history. Weather is ancient and ever new. It toppled empires long before satellites, yet it still surprises us even now, despite all our computers and forecasts. It whispers through the wings of butterflies, glows in the shimmer of a rainbow, and roars in the voice of hurricanes. It is chaos and pattern, danger and beauty, a reminder that birth is alive beneath our feet and above our heads. Perhaps, as you lie here now, you can imagine the sky outside your window, slowly shifting in its own quiet way. Maybe a breeze stirs the leaves, or a faint cloud glides across the moon. Even in this stillness, the atmosphere never rests. It is the great breath of the planet, circling endlessly, carrying the seeds of tomorrow's storms and the calm of tomorrow's dawn. As you drift towards sleep, let the thought of weather be a comfort. Its cycles remind us that change is natural, that after every storm comes calm, and that nothing ever stands still forever. The same skies that once glowed orange in Earth's infancy now glow above you tonight, steady, timeless, and full of wonder. Thank you for joining me on this journey. If you've enjoyed this gentle exploration, I invite you to subscribe and return again. There are many more nights of science and story waiting for you here. But for now, let the winds settle, let the clouds fade, and let your thoughts grow lighter. Rest in the rhythm of the sky, in the hush of Earth's heartbeat, and in the quiet knowledge that you are part of this vast, ever-changing story. May your dreams drift like clouds on a gentle breeze. Good night.